The octet rule is an incredibly important rule in chemistry in helping us determine Lewis dot structures, and once we have Lewis dot structures, we then can predict molecular geometry. However, there are exceptions to the octet rule that you need to be aware of. First, we know that hydrogen is always an exception to the octet rule. Once hydrogen forms a bond, a single bond, it's done. It can never ever form a double or triple bond, and it will never be a central atom, and it can never have lone pairs on it once it forms a bond. Another exception to the octet rule occur in species known as radicals or free radicals. These are molecules or ions or atoms that have an unpaired electron and are incredibly reactive. For example, this hydroxyl radical is formed from pollution, and it can react with biological molecules and do a lot of damage, particularly in lungs after it's breathed in. However, sometimes free radicals are important. For example, nitric oxide is a free radical, and it's a short-lived messenger chemical in human beings. Another exception to the octet rule occurs in a situation known as expanded valence. And this happens with atoms in the third row of the periodic table and below. And looking at the third row, the two important atoms or elements biologically are phosphorus and sulfur. And phosphorus and sulfur can accept more than 8 electrons. And we see this example here where we have phosphorus pentachloride or PCl5. When we draw the bonds between phosphorus and each chlorine, we see that phosphorus has 10 electrons around it. So phosphorus and sulfur can accept more than 8 electrons, and we will see that occasionally where there are more than 8 electrons around phosphorus and sulfur in biological molecules.